Good afternoon, Dev Days. Now, just in case anyone didn't know, there has been a change to your scheduled program. Victoria could not make it, so I'm afraid you will not be learning about how to build security-oriented microservices. Instead, my name is Beattie, and I am going to be talking to you about something I call the pursuit of APIness, the secret to happy code. A little bit of background about me. I've been building websites since 1992, so it basically forever in internet years. I'm a Microsoft MVP. I run the .NET user group in London, in the UK, where I live. Email and Twitter and all kinds of details are on here. If anyone wants to, get in touch after the conference, you have questions, anything you want to talk about, always, really happy to chat about these kinds of things. And for the last 15 years, from 2003 until Friday, when I finally left, I've worked at a company in London called Spotlight. And Spotlight's customers are professional actors and theaters and films and television companies. And films and theater, whenever you sort of deal with agencies and things, they always give you the same clip art. They're like, oh, it's a theater company. We have to use these masks. And these are Greek theater masks, happiness and sadness, comedy and tragedy. And the reason I open with this is what I'm going to talk to you about today is the things that we as developers can do to create a difference. There are some days when the code you're working on is just, miserable. You're really not enjoying what you do. You're not enjoying your job. You're not enjoying your work. And there are other days when you kind of, you go in and you're getting everything done. Things are working. You're smiling. It's nice. You go home on time. And there's actually a lot that we can do to control how other people have those kinds of experiences. So the one thing, I'm talking about happiness, Now, I want to be clear, I'm not talking about, mental health and stuff here. I'm just talking about how not to be grumpy. I'm talking about patterns we can put in software that just makes it more enjoyable for other people to work with. And I'm going to be talking about two ideas here. One of them is this idea about discoverability. Discoverability it's a name that we use for a system that you can explore, a system that you can investigate for yourself. You can poke around, you can play with it, you can discover how it works, and you can work out on your own what the system is capable of and how you can use it effectively. Now, this is very closely tied in to a phenomenon that exists in neurochemistry. There is a chemical, a neurotransmitter in the human brain. It's called dopamine. And when gamblers win, they get a rush of dopamine. Dopamine is the addiction chemical. It is the thing that gets you hooked on things and keeps you coming back for another go. But the other thing that we get a dopamine release when we solve a problem, when we solve a puzzle. If you've ever had one of those nights where you sit up and you're writing code until 4 o'clock in the morning and you keep thinking, I'm going to stop. And then you're like, oh, I made that bit work. No, I'm going to stop. No, I made that bit work. And it's just these little kind of 5-10 minutes. And every 5 minutes, just as you're about to shut down and go to bed, you get this little rush of dopamine and your brain goes, oh, yeah, it's brilliant. Let's do another bit. You're actually, at that point, you're almost addicted to the programming, the work that you're doing. But the really interesting thing about dopamine is when your brain is releasing it, you are better at learning things. You actually, they've done these studies where they study people learning things by solving puzzles as opposed to reading the manual. And the people who learn through problem solving, they get this dopamine rush. They remember the information. They take it in more quickly. They remember it for longer. So if we can build systems that feel like solving puzzles, people will get hooked to working with them, which is good because it means that they'll get productive quickly. They'll get this dopamine rush. They'll be happy. They'll enjoy working with it. And they will get more productive more quickly and be able to use the tools and the frameworks and platforms we created to do things, which I think is pretty cool. Let's talk a little bit about this idea of something we call learning curves. Now, learning curves are basically experience. How long have you spent working with something? And expertise is how good are you? How proficient are you at working with that? And sometimes people will say, oh, there was this really steep learning curve. And they say that like it's a bad thing. So we got two curves here. We got a blue one, which is kind of steep, and we got a red one, which is kind of shallow. So just by show of hands up who thinks the blue curve is better. Hands up who thinks the red curve is better. Hands up who thinks it's a stupid question. Yeah. They're both fine. Now the steep learning curve, a steep learning curve is hard work, but what it means is you get very, very competent very, very quickly. So this kind of curve here, this is someone who goes home and they teach themselves Scala in one weekend. And they come in on Monday, it's like, I didn't know you knew Scala. And they're like, oh yeah, I read it over the weekend and now I know it. And this one is like someone who's been using Microsoft Word for like 5 years and they still don't know how to do a page break. And they're just kind of gently, they don't really learn anything. Years and years of experience, but they're not really pushing themselves to get better at that. Thing is, both of these are okay. The thing that we need to avoid is this thing here, and this is what we call a localized peak. Now, has anyone in here ever worked with ASP.NET Web Forms? So ASP.NET Web Forms, in case you've never come across it, it was a Microsoft programming framework for building websites that they launched about 15 years ago with the first release of .NET. And it looks great in demos because you can take a button and you can drag it from a toolbox and drop it onto a web page, and then you click it and you write some code. And, and people got very, very good at building complex systems using all of these components. And then one day your boss comes to you and says, we need to build the client wants a streaming video player. And you look in the toolbox, and there's no streaming video player there. So you're like, okay, how hard can it be? And you start reading about it, and you discover all this stuff with HTTP that you had no idea, like chunk downloading and buffering and gzip and compression. And you're like, all of this stuff I learned, all this stuff that I learned to do web forms, it's not actually true. They lied to me. It's an abstraction. The web is not actually made out of buttons and data grids. The web is made of requests and responses. And now I've got to forget all this stuff that I learned, and then I got to start again, and I got to get all the way up here to be able to build a streaming video system. It's a localized peak, and when you have to create abstractions in software, you can't just hit someone with the full complexity of everything right from day one. But when you're creating abstractions, be very, very careful. Don't create this, because the person who's just got to this point, they're going to go home really, really unhappy, because they're like, I put all this work in, and it was stupid, and I learned all this stuff that doesn't matter, and now I got to start all over again. That is not a good experience. You ever get these things in, when you see tutorials online, and they're like, hey, we're going to show you, this is how you draw an owl, step-by-step instructions. Step 1, draw an oval for the head. And then step 2, you draw an oval for the owl's body. And step 3, you draw the rest of the owl. And you're like, what happened there between step 2 and step 3? What was that bit? This is that kind of learning curve. It's a brick wall. It's like, yeah, easy, 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 bang, monads. And you're like, hang on, I don't get how you got from down here. I was okay with recursion, and then suddenly you're talking about monads and type amplifiers and endofunctors and what? Basically, it's broken. There's no easy journey to get from being a beginner to being kind of intermediate and being competent. So what you want to do is look for points in your systems where this thing happens, where you have this brick wall. Now, there's the earliest example I saw of this, the first thing that really started me thinking about the ideas that ended up becoming this talk, was about 10 years ago. I was trying to use a thing called Castle Windsor. And Castle Windsor is an IOC container for .NET, open source, and I read about it on someone's blog and thought it looked interesting. So I downloaded it, and I installed it, and I pressed go, F5 run, and I got the yellow screen of death. And I thought, oh, crap, it didn't work. And then I thought, hang on, look at this. Look at what this error message here actually says. It says, looks like you forgot. So one, it's being friendly. It's not saying you're a newbie idiot and you don't know what you're doing. It's saying, hey, looks like you forgot to register the HTTP module. To fix this, and then it gives you this little chunk of XML. And you copy that out of the error message and you paste it into your configuration file and you press refresh and it works. And so one, dopamine rush, you've solved the problem, you've solved the puzzle. 2, this is really friendly. You think this is nice. The people who built this framework, they understand it. They want me to succeed at using the thing that they created. And 3, because the answer is actually in there with the XML inside the error message, you can fix it straight away. There's no brick wall. There's no gap. And because you solved the puzzle, you got the dopamine rush, you'll remember it. Next time you go to set up a project, you'll be like, hang on, I remember that I need to put the per request lifestyle module in to make this thing work. Now, what we're talking about here is user experience design. And there's a lot of companies where they're like, well, we have a UX team. We're just the back-end developers, or we're just databases, or we're the ops team. We don't need to do that because we have devs who look after that, team who look after that for us. That's not the case. Every time you create any piece of software, any code base, library, API, interface, anything, you're creating a user experience. Somebody else is going to be using your code. They're going to be running the stuff that you built. And by learning a couple of sort of simple tricks and techniques for doing better user experience design, we can make all of those systems better, easier, faster, more productive, and happier to work with. Let's run through a scenario. You've just joined a new team. You're starting, it's first day, you're in on Monday morning, and, you get into your new office, and one of your coworkers says, all right, welcome, there's the coffee machine, the bathrooms are over there. Okay, here you go, get the website up and running locally. And you think, all right, I can do this, and you start poking around. You go and have a look on GitHub, and there's a repository on GitHub called website, and you're like, that's probably it, and you clone the repo, and it's empty. You have a look, no branches, nothing. You're like, okay. And then you see website 2018. You think, maybe that's it. And you clone that repo, and that one's empty as well. And then you see new website, and you think, okay, and clone it. And after, half an hour of this, you turn to the guy sitting next to you, and you're like, hey, really sorry. He takes his headphones off. He's like, what? I'm like, I can't find the code. Where's the website code? He says, it's in a repository called sales. And you're like, why? And he says, well, the sales team were the ones who built the original website, so it's named after them. Yeah, okay. You clone the sales repository, and you press build, and it says, can't find mycompany.accounts.dll. You type it in Google. Of course, Google's never heard of it because it's mycompany.accounts. It's a private package. So you turn to your new coworker, and you're like, I'm really sorry. Headphones off again. What? Do you have my company, the DLLs? He's like, oh, yeah, I'll share my C drive with you. Just everyone, full control. Just copy out whatever you need. And this goes round and round and round. And, maybe if you're lucky, by the end of the day, your coworker doesn't hate you, and maybe you've got the code up and running. But if you're unlucky, you're just going to hit, complete brick wall. Somewhere you can't go past this point. You can't Google it. There's nothing you can do here. Now, this is a real error message that somebody at Microsoft thought was a good idea to put in a product aimed at software developers. Somebody knew what went wrong. Somebody understood at some point in time what operation was trying to be completed. And what does it mean, unspecified A? What is this even? Why would anybody ever write this? This kind of thing is just miserable, It makes people really, really frustrated. You're like, and you end up ranting on Twitter and going on Stack Overflow and going, I got an unspecified error. And they're like, can you give any more detail? You're like, no, I got this dialog box. That's it. I once said I was trying to install a Visual Studio 2017 last year, and it kind of, churns away for about 5 or 10 minutes. And then it pops up a dialog that says, please fix the following problems before continuing. And there's a list box, and there's one word in the list box, and it says Asia. And I'm like, what is this? Like, I can't fix Asia. I'm not the United Nations. Complete brick wall. I ended up just reinstalling Windows to get the thing working. So these kind of experiences, they are bad. So let's run the same story. You've quit that job because it wasn't very good. And you joined another team, and you get in, and it all feels very familiar. It's your first day. They say, hey, there's the bathrooms, there's a coffee machine, let's get the website running locally. And then just as he's about to put his headphones on, your new coworker says, by the way, the website project is called Applejack. Okay, you go onto GitHub, Applejack, bang, there it is. You clone the repository. You press go. Up comes a screen. The screen says, hey, first thing you notice is it's installing NuGet packages. And you look closely, and it's like, wow, NuGet.mycompany.com. Somebody's taken all of those DLLs, and they've put them on a private NuGet package server. So when you press build, it just installs all of them. That's pretty cool, And then it comes up and running. It has a screen saying, hey, looks like you're running Applejack for the first time. You're going to need to set up a database. In the repo you just cloned, there's a folder called SQL. Run the scripts. You do that, it works. So bang, dopamine rush, you solve the problem. You're going to remember that there's a folder called SQL, which has all the database scripts in it. And you're up and running. The whole process has been really smooth. Probably takes about 2 hours. After a while, the person next to you takes his headphones off. Is like, hey, come on, let's go and get some lunch. And as you're walking out to lunch, you say, why is the website called Applejack? And he says, we name all our projects after ponies. And you're like, why? And he's like, we just needed names. We just needed a system of code names for things. It's just like an internal name. It doesn't go on the marketing material or anything. But we just picked them all. And when we got to the website, we decided that Applejack was the next My Little Pony we were going to use. Just by giving it a name, just by giving, in software, we have these ideas of bounded contexts and domain boundaries and components. And it's amazing, just by giving something a name, how simple everything becomes. So suddenly you have a name for the GitHub repository. You have a name for the documentation. You go and search on the wiki, you type in Applejack, bang, there's everything that anyone ever wrote on that wiki about the website project. If you have things like, logging messages, notifications, pager alerts, all these kinds of things, get an email from applejack@mycompany.com saying, hey, we're seeing really weird response times. It's like, I know where it came from. I know it's the website project. And after a while, it actually starts to feel friendly. And you start thinking of distributed systems as all these little characters with names kind of interacting with one another. Okay. Time for another history lesson. First computer I ever wrote code on looked kind of like this. Back in 1989, it's 286 PC. It had a megabyte of RAM. And I had, hassled my parents for weeks to get me a computer. And I finally got this computer that I wanted. And I switched it on, and it went, A. And I went, hello. And it went, bad command or file name. And I was like, I didn't mean to be bad. I want to play with my computer, please. Maybe it has a menu. Bad command or file name. Help. Bad command or file name. I'm thinking, this isn't what I had in mind at all. Just for a bit of fun, the most fun thing you could do with MS-DOS is you could say, if you're happy and you know it, syntax error, and it would go, syntax error. But basically, that A prompt was just like a brick wall. It's a dead end. You're like, okay, I'll read the manual. And the MS-DOS 3.3 manual was this big, fat book about 2 inches thick. It was horrible. And you sat there going through it going, I thought computing was going to be more fun than this. Now, around the same time as we had the 286 PC, we also had the Apple Macintosh. And when you switched that on, you got a little smiley face on a picture of a computer. And it says, welcome to Macintosh. And you're like, this is pretty cool. This is doing things. Something is happening here. And it would whir away for a couple of seconds. And then, when it finally finished booting, it would bring up the desktop. And the desktop had things on it that kind of looked recognizable. Like this thing here looks like a trash can. And you're thinking, maybe I can use that to throw stuff away and, get rid of things I don't need. And there's file, and there's edit, and there's view, and there's label. And, and once you get the hang of using the mouse, you can start poking around, and you can click on things, and you can see what they do. So instead of just a black screen with A, it's got what we call affordances. It's got ways, it shows you ways that you can interact with this system. Now, what sometimes happens, particularly when developers are building user interfaces, is they go, affordance is good. We should just put buttons on the screen so people can see what the product does. And you get this. I mean, it's easy, right? This is how you write programs. You type your program here, and then you just click the buttons to do the things that you need. This is Visual Studio 2017 with literally every single toolbar and menu and option all switched on at the same time. And this is as bad as MS-DOS, you have no idea what to do with it. Sure, you can click on stuff, but there's no context. There's no kind of indication saying, this thing here, start, this is quite important, and this thing here, the UML Model Explorer, you're never going to use that in your entire career. You might as well switch it off. We put it all on the screen, and it's just like, here's all the things. What you want to try and do is to create systems which encourage exploration by rewarding it. My favorite example of this is here.
Good morning. You have been in suspension for 50 days. In compliance with state and federal regulations, all testing candidates in the Aperture Science Extended Relaxation Center must be revived periodically for a mandatory physical and mental wellness exercise. You will hear a buzzer. When you hear the buzzer, look up at the ceiling. Good. You will hear a buzzer. When you hear the buzzer, look down at the floor. Good. This completes the gymnastic portion of your mandatory physical and mental wellness exercise. There is a framed painting on the wall. Please go stand in front of it. This is art. You will hear a buzzer. When you hear the buzzer, stare at the art. You should now feel mentally reinvigorated. If you suspect staring at art has not provided the required intellectual sustenance, reflect briefly on this classical music. Good. Now please return to your bed.
So you see the way it's got little hints popping up on the screen that are actually teaching you how to play the game as you go along. They're teaching you the instructions. They're teaching you how to interact with the system. Now, that's from Portal 2. I like it. It's funny. It's interesting. I'm going to show you a real example. So this is Microsoft Edge, and it's the new browser that ships with Windows 10 and modern Microsoft operating systems. It's a complete replacement for Internet Explorer. And the first time I downloaded this, I went, right, cool. I'm a web developer. Let's see what this thing can do. And I go into Edge and I right click and I get this. And I'm like, where's my stuff? I'm a serious engineer. I need all my tools and things. Where's Inspect Element? Where's View Source? Where's all the stuff that I need in order to build websites? So I go poking around and I click the little hamburger menu and I see this thing, F12 Developer Tools. Found it. So I solved the puzzle. And look, this one says F12. None of the others have a number on it. Maybe next time I can just press F12. But then the really smart part is once you switch that on, it says Inspect Element and View Source will now appear in the context menu. So I've done a little bit of exploring, and the system has gone, we understand. I can see what it is that you're trying to do here. Brilliant. Well done. And it's at the exact moment when you're looking for it, then you can go and Inspect Element and View Source now appear, and you've got all the webmaster debugging tools and all those kinds of things. Now, you can apply these kinds of principles at all sorts of different levels in software systems you build. There is a thing which I'm sure is familiar to many of you, which is called intelligent code completion, which is where for example, you type console dot, and then you're like, I have no idea what the console can do. Oh, look at that. It's got a foreground color, and that equals console color dot. Oh, look, these are the options I have available. And by doing this, you don't need to go and look at documentation because you can just type console dot this, console dot that. Now, I'm sure, everybody here has worked with systems like this that use intelligent code completion. We've all done it. The question that I want to ask is, how many of you have ever actually used this in your own code? Now, I've been writing .NET for 15 years, and every time I need to connect to a SQL Server database, I have to stop and look it up because I cannot remember how to write a connection string. I just can't. It won't stick. So you get to here, and you're like, okay, well, there's documentation, string SQL connection. That doesn't help me. I need to stop. I need to Alt-Tab. I need to switch out. So what I did is I wrote this little static helper method called SQL.connect, and I put the documentation inside the helper method. So at the exact point where I'd normally get stuck and need to go and look it up online, this little screen pops up for just long enough for me to write my connection string. And as soon as I close the quote thing, it goes away. And the way that you do that is really, really simple. If you have a look at the back-end code that's behind it, it's just a specially formatted comment above the method. If we look at the definition, all I've done is taken this little piece of code from the website that I always go and look it up, and I've pasted it into the parameter documentation for that SQL.connect method. The exact moment you get stuck, it just jumps in and helps. It's like, hey, you've hit that brick wall again, the same place you always do. But last time we were here, we did something to help. This is very good when you have people following a sort of known journey, when you understand what your user is trying to accomplish. But quite often, you won't know what it is that they're trying to do. You need to, as well as just giving them these sort of helpers and IntelliSense and code completion to get through brick walls, we also want to use signposting. We want to signify the places you can go and the operations that are available from here. Now, I talked about this in a workshop that I did here yesterday, all about building REST and hypermedia APIs. I'm going to show you a live example from a production system. So this is a REST API that my team at Spotlight put together. And what we did is we started out with this JavaScript tool that we built as an internal tool for us to use to work with it and develop it. And it proved so useful, we actually ended up shipping it. So we deployed this onto our live production system. You can point a web browser at it. You can switch here between the test and the live system. So we've got our sandbox environment and a production environment. They're both out on the web. And when you hit go, it pulls back some JSON, but then it runs some script that turns that JSON into content you can read and you can click and you can navigate. And so you can actually use this tool. You don't have to read the manual to find out how our API works. You can literally go in and play with it. And we expose, as well as these navigation links, we use something called hypermedia controls. So once you actually get onto one of the actor's profile objects that you're working with, you can see here we've got actions that will let you delete and update. And if you hit update, this will allow you to actually go in and format the request, send it directly, and see what it does. Now, the reception we had for this was so good. Because people were just like, this is brilliant. We don't need to read the documentation. We can literally just, if somebody has a problem and they're trying to get some code on their platform to work and they think there's a problem with our API, they can use this to try it. And if it fails, they can ping us and go, hey, I just did this on your API Explorer, and that for us is the best possible set of reproduction steps for that bug. Because we got people using this whose code is written in PHP and Ruby and all kinds of things. The endpoint's written in .NET. If someone sends us some Ruby code that doesn't work on their machine, there's very little we could do to support it. But by using this interface, they can be like, paste this in there, click that, and it fails. And we're like, yep, we can see it fails. 500 server error. So this combination of the REST and hypermedia architectural patterns and putting this very simple user interface on front of it actually makes a much more compelling story for people who want to use our API than the whole go and read this documentation and then sign this agreement and accept the terms and conditions, all this kind of stuff. Okay, so we've talked so far about writing code. We've talked about all the stuff that you can do with code while it's still in the process of being written. What we're going to talk about now is running code. So you get into work one morning and the telephone is ringing and you pick the phone up and someone says, there's a problem, the system is down. And you're like, okay, look, I'm really sorry, I've just got in. Let me take your number and I'll give you a call back. And you hang up and the phone rings again. You pick it up and someone says, the system's not working. You're like, which system? And they say, the computer system. You're like, thank you, that doesn't really help. And you put the phone down. And after 3 or 4 calls, you finally get somebody who's like, do you want me to send you a screenshot? And you're like, yes, thank you, please send me a screenshot. And they send you a screenshot and it's this. And you're like, okay, request timed out. That's why the system is down, obviously. And your boss says, hey, come on, the system's down. How long till it's up? And you're like, well, we know it's a request timeout, and we've only got 58,000 lines of code, so I'm just going to look through all of them and look for the request timed out one. Probably only takes 6 or 7 weeks, Maybe we'll get lucky. And so your boss is yelling at you, and the customers are yelling at you, and the boss wants to yell at the customers, but they can't, so they're yelling at you twice as much instead. And everyone is kind of very angry and very kind of at each other, and the whole thing is just a horrible, horrible situation. So now let's say same problem occurs, but instead of a red telephone in your office, you have a big flat screen TV with a dashboard on it. And what you've done with this dashboard is you've connected endpoints to each of the kind of critical systems. And you walk in and, before you even notice whether the phone is ringing or not, you're like, hang on a second, something's not right. Okay, so what have we got? The content delivery network is down, the intranet's down, the main web stack is down. Okay, so everything else is good. This is fine, this is nice. Email's working, databases are working. Problem with the CDN, well, I know that if the CDN goes down, it'll take down the main site and the intranet as well, so let's go and have a look at the CDN. You jump on Slack, Skype, whatever, and you say to the team, you got a problem, website's down, we're looking at it, next update in 15 minutes. Your boss is like, oh, cool, all right, thank you, I was just about to see if you were working on this. If you're very lucky, your boss will be like, do you want some coffee or anything? Can we go out and get some sandwiches? One of the weird side effects that we noticed after, this is a real picture of a real dashboard. Whenever you work in an office, there's the people who kind of come around and they want, money for the lotto or someone's birthday and they're collecting for a gift. And if they see the screen is red, they don't bother you because they're like, maybe now is not a good time. And instead they'll be like, is everything okay? I noticed that the screen's red. And it kind of gets everyone on side. Everyone's on the same, and they feel like they're all part of the same team that's trying to fix this problem that's going on. And, even people who don't know anything about code and infrastructure will be like, do you want some coffee? Can I get you some water or something? It's just a really nice way of kind of communicating, we got a problem, we're working on it, it's transparent, it's up there where everyone can see it, makes for a much, much happier experience. Now, monitoring is a little bit like designing user interfaces. What you don't want to do is to expose a endpoint for absolutely every single system. In any decent-sized organization, there will be a bunch of stuff that at any given point is not working perfectly right now. Your database is a bit slow because it's running a transaction log backup that happens every 20 minutes. You don't want to monitor every single system. What you want to do, think about the dashboard of a car. There's thousands of components in a car, but when they put it up on the dash, they come up with maybe 8. They're like the electrical system. Yep. Yes or no. The ignition coils, yes or no. The speedo, yes or no. The fuel gauge, yes or no. The high-level things that give you just enough warning. There's a problem. It's probably over here. Please start investigating or, take it into the shop. Now, I grew up on Star Trek, The Next Generation, and one of the things that I always loved about Star Trek is that this thing, the warp engine of the USS Enterprise, is right out there on display where everyone can see it. It's actually part of the show, and there's a couple of episodes where you see the engine room, and this thing isn't lit up. It's dark, and immediately there's going to be a big problem in this episode because the engine's not working. It's this wonderful way of just, creating transparency and communication, and it's not, they haven't hidden the engine away behind panels or something. Because, they could easily have got away with that. But they're like, no, we want to put this thing out where everyone can see it, where it becomes part of the landscape. You can use the same idea in software systems you build. You're going to have components and endpoints and all kinds of things in your system that are useful to you when you are developing it. you can expose those in production. I'm going to show you another short video demo. This is a thing called Nancy. Nancy is a framework for building websites and APIs on .NET. And Nancy has a built-in monitoring dashboard. So any Nancy application, you just go to _Nancy, you set up a password in the config file, and this is basically like taking the panels off your car while the engine is running. This is all live stuff. So this is showing you the internal state of a live running production system. You click on information and it's like, hey, this is what we're doing. These are all the versions. These are your components. These are all the providers that have been instantiated. And one of the places this is really useful, if there's an error in one of your config files, reading the config file will tell you one thing, but it doesn't actually tell you what's happening on the running system. Maybe you think you've deployed the latest version, but the deployment failed. You can go and have a look. This thing will show you all of the routes and all the URLs and all the HTTP endpoints that have been configured and are available right now on this running system here. You can even go into the settings and you can switch on a thing called request tracing. And you can say, I want you to capture, just while this is switched on, I want you to capture all the real traffic. You can go in, you can grab any one of those requests. And this is like being able to run the Chrome Network Inspector, but from the other side. You can see what's coming in from the perspective of the server. You can see all the HTTP headers. You can see all the stuff that's being added by your load balancer. It gives you this incredible degree of insight and visibility into the way that your live system is actually behaving. And as soon as you're finished, you just go into settings and you switch it off again. So you can switch it on for just long enough, look at what you need, work out what the problem is, go back and switch it off. Now, that's brilliant for working out what your system is doing right now. To really get insight into it, you need to go a little bit further and you need to understand what it was doing previously, which is why we need to talk about logging. Because without logging, you get into work, there's a problem, you're like, oh, what's the problem? Oh, look at that. Our database server has just hit 100% CPU consumption. Well, that's a problem, you know. How did it get there? Because without understanding the history of how this happened, you can't work out how to fix it. Maybe first thing this morning, everything was fine, and then this happened. You know, maybe something has been gradually ramping up over time. Maybe the historical CPU graph looks like this. There's some kind of batch process running. Or maybe it's been ticking along absolutely fine, all along, no problems, nothing at all. This is probably someone deploying something stupid to production. But each three of those tells a very, very different story about this data point and how you should go about investigating it. And the time perspective matters as well. If this is one day, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, you're like, okay, well, if it's the green one here, you're like, what do we do every hour? Are we running a backup? Is there some kind of calculation job that runs every hour? If it's the blue one, you're like, that's interesting. What's that? Did we send out like a massive email overnight to all our customers and people have just been pouring onto our website all day? If it's the red one, you're like, who deployed something? Has anyone just shipped anything to push out a component maybe that had a bug in it? If this time axis, instead of being 10, 11, 12 o'clock, is January, February, March, you know, at that point, it's a different set of investigation. This green line here, you're like, what do we do every month? Do we have like a monthly sales report that's just been getting bigger? Is this some kind of log shipping process? The blue line, you're like, we've been growing. Something's been getting bigger month on month on month. And what's really nice is if you can track this, you get to here, and you can turn around to your, chief finance officer and you can say, we are going to run out of database capacity on the 15th of July at 4 o'clock in the afternoon. So can we please have some money now so that at this point here, we can provision another bigger virtual machine or get some new infrastructure or do some investment in it? And they go, how do you know? And you're like, look, this is the graph. We need to fix this now. Otherwise, on 15th of July, we're going to have a problem. This is brilliant. People love being able to make these kind of proactive decisions about investing in infrastructure. The red line, unfortunately, is probably that you haven't deployed anything broken for the entire year, and then suddenly, boom, you shipped something, and it didn't work. There's a tool called SQL Monitor, which is a Redgate. It's a proprietary tool that you just point at your database servers, and this is a real graph, and this actually shows you on one of our production database systems the way all of the metrics and behavior change over a typical 24-hour period. And you can literally see in here, so this is 24 hours on, I think this is like a Tuesday in the UK for a company that specializes in theater. So everyone comes into work about 10 o'clock. Around 12 o'clock, they start using our website to do all kinds of work. About 6 p.m., bang, they all go home. They go to the pub or they go to the theater or they just knock off. They don't work late. And the first thing anyone says, we've got a problem, I'm like, what did yesterday look like? Is today, is this just a slow growth that's been happening over time? Now, This kind of system activity monitoring is really useful in terms of what was the impact on the underlying systems. But what you also want to know, what was your code doing? And the way we do that is with logging. And the biggest problem with logging is get the logs off your servers and onto one big central logging platform, whatever that may be, database, SQL Server, cloud service. Just get it all in one place, because the second you do that, one, the individual boxes now don't matter. If you lose a box, you don't lose all the logs with it. You want to be able to recover those and see what happened. But you also need to establish some consensus around what the levels mean so that all the people on your team are using the same words to mean the same things. We have 5 levels of logging in most frameworks: fatal, error, warning, info, debug. The way that I kind of define these, fatal means this is a big deal. Wake people up. Stop what you're doing. Now, in most organizations, there's probably a couple of software systems that can't have a fatal exception because they're not that important. You got a system that you use to send an email every Wednesday afternoon. You don't care if it breaks over the weekend. You don't want to get out of bed. Someone phones you, hey, the marketing email system is not working. It's like, why are you even looking at that at 4 o'clock in the morning on a Sunday? Chill, we'll fix it on Monday. That's not fatal. Errors and warnings are things that happen. Failure in software is inevitable because no network is perfect, no disk space is infinite, there's always going to be latency, systems will fail. The point about these is you want to watch for volume. You want to watch for lots of them happening. The distinction I have, an error is the kind of thing someone gets a timeout, they press refresh or they press F5, next time it works. Warnings, maybe you had to fall back to using cache data, or maybe you had to retry a transaction deadlock. These kind of things happen, they're inevitable. 1 or 2 you don't want to know about. Now, what you want to look for, if you imagine you get on the bus and, there's someone there dressed up as Jack Sparrow or dressed up as a Jedi Master or something. You're like, all right, it's one person on a bus, they're going to a costume party. If you get on the metro and you see this, you're like, this is interesting, Errors and warnings are like people on the metro wearing fancy dress. If there's 1 or 2, that's normal. If you see this, something interesting happened. Info kind of means, everything is fine. Info is reassuring messages. The main value in info messages, you come back after a long weekend, say you've been off work for 3 or 4 days, you come in, you look in the log files, empty, nothing. There's 2 possible explanations. One of them, you've had a perfect weekend. There have been no network timeouts, no latency, no errors, no deadlocks, nothing. What's the other possibility? It wasn't running. The log infrastructure has failed. So, log info is just checking in, Every 5 minutes, just put a thing saying, hey, it's all good. We just recycled the cache again. Everything's fine. Because then when you come in, you're like, wow, 5 minutes, we've actually been up. We've had a perfect home run this weekend. Good work. Debug is for everything. Now, debug, one of the good habits you can get into as a developer, the first time you go for like a console.write line or, a standard out.print or whatever, stop. Get some logging frameworks in, use log.debug, set that up, start using that for everything instead. Log all the things, everything that's useful to you when you're developing that system. Yeah, it's a lot of stuff, but when you deploy to production, you can switch it off. You just set the level and you're like, okay, you're on prod now, don't log the debug messages anymore. Really good libraries will actually compile down to a point where that debug.log just becomes a NOP, no operation. Because at some point, you are going to have a problem that only occurs in production at 4 o'clock in the morning. You can't make it happen during the day. You can't make it happen on dev or local or staging, anywhere else. And at that point, you switch on the debug logging and you've got the trace. You can see everything that's going on. You've got this much better level of visibility. I think all the confusion around logging could actually have been fixed if they just picked different names for all the things. Log.fatal shouldn't be called fatal. No one really knows what fatal means. If you want fatal, you should have to write in your code, wake me up at 4 a.m. on a Sunday. Log.error should be apologize to the user and raise a ticket. Log.warn should be tell me if this happens 1,000 times. Info should be everything's fine, just checking in. And log.debug, to remind you to switch it off, should be called fill my C drive with stack traces. So there's a Daniel Librero, who I think worked for Google. He had this post with this idea that I sort of took and extended a little bit. But yeah, that's what I think the log levels should be called. Now, just to recap, finish up. The rules of writing happy code, building systems people are going to love to work with. Remember Applejack and the My Little Ponies, You have bounded context, give it a name, and use the name. Use the name in your repos. Use the name in your logs. Use the name in your dashboards and your monitoring and your wiki and your email. Use that name everywhere you can, because names are a really good way of creating bounded context. And don't get hung up on naming. Pick a list. My Little Pony, different kinds of single malt scotch, capital cities, anything that just next time you need a name for something, you can just pick the next one off the list. People are going to laugh for 2 or 3 days, and then they'll get used to it. They really will. Learning curves. Remember the owl. If you're creating systems, don't do the one oval, rest of the owl. Keep them smooth. A steep curve is fine, shallow curve is fine. Watch out for localized peaks. Don't invent web forms. If you're throwing error messages, put as much information as you can into the error message. All the detail. You know what was going on at the point where your code blew up. The person in 3 months' time who's looking at it, which might be you on a bad day, they don't have that context. Don't do this. Just never do that. Why would anyone even do that? Remember signposting. Put clues in your software. Signposts, labels, links, hypermedia controls, actions, intelligent code completion. Help people find their way around the systems that you are creating. Be transparent. Expose things. Take the panels off the engine. You leave passwords on. You don't put the stuff wide in the open. But allow yourself and your team, your monitoring people, to actually get some visibility into what the live running system is doing right now. Build yourself endpoints that exist for no reason other than that you can plug monitors into them, and they'll tell you the current status of the running system. And the golden rule, the rule to rule them all, is remember we are creating user experiences. Even if you think you're not, somebody somewhere is going to end up running the code that you're writing today, and it's completely up to you whether they're going to have a good day or a bad day. Thank you.